May 7th, 1941, Berlin, Germany, Office of the Reich Ministry of Armaments and Munitions. Colonel Fritz Gernert, aide to Armaments Minister Fritz Todt, placed a translated American newspaper article on his superior's desk with a slight smile. The story from the Detroit Free Press described how Henry Ford planned to build a factory that would produce one complete four-engine bomber every hour using automotive assembly line techniques. "American propaganda," Todt said dismissively, pushing the paper aside. "Their automotive industrialist thinks he can build complex aircraft like Model T cars. Pure fantasy." German military intelligence had been monitoring American industrial mobilization since President Roosevelt's Arsenal of Democracy speech in December 1940. While German experts acknowledged America's automotive production capacity, they remained convinced that aircraft, especially heavy bombers, required skilled craftsmen working in traditional aviation facilities. The precision, complexity and technical requirements of modern military aircraft made assembly line techniques impractical, perhaps impossible. What the Germans couldn't yet comprehend was that they were witnessing the beginning of the most dramatic industrial transformation in military history. Ford's Willow Run plant wouldn't just build bombers. It would revolutionize the mathematics of modern warfare and render traditional aircraft production methods obsolete. The American newspaper article that Todt dismissed so casually described the construction of a factory spanning 3.5 million square feet, the equivalent of 70 football fields under a single roof. It would employ over 42,000 workers and apply automotive mass production principles to the consolidated B-24 Liberator, the most complex aircraft then in production. Each bomber contained over 1,550,000 individual parts, 360,000 rivets, and miles of electrical wiring. German aircraft production in 1941 remained largely an artisanal process. The Messerschmitt factory at Augsburg employed highly skilled craftsmen who built aircraft in small batches, often modifying individual planes based on materials availability and evolving design requirements. A Messerschmitt Bf 109 fighter required approximately 4,000 man-hours to complete. The Focke-Wulf factory at Bremen operated similarly, with teams of specialists working on individual aircraft through most stages of production. This production methodology had served Germany well during the Blitzkrieg phase of the war, when tactical superiority and experienced aircrews gave the Luftwaffe dominance over smaller nations with limited industrial capacity. But Germany had never planned for a prolonged production contest against a fully mobilized United States. The entire strategic calculation of Blitzkrieg was to achieve victory before American industrial might could be brought to bear. If America truly enters the war, Luftwaffe General Ernst Udet had warned in 1940, "We will need to increase our aircraft production tenfold merely to maintain parity. Our current methods cannot achieve this." Udet's warning went unheeded. German leadership, focused on immediate operations in the Soviet Union, dismissed the American threat as too distant to warrant strategic concern. When intelligence reports about massive American aircraft factories began arriving in early 1942, they were often downgraded in importance or dismissed as exaggeration. This dismissal represented more than strategic misjudgment. It reflected a fundamental misunderstanding of how industrial capacity would determine the outcome of modern warfare. The Germans believed in craftsmanship, technical excellence, and tactical superiority. The Americans believed in production volume, standardization, and overwhelming numerical advantage. The mathematics of this divergence would prove decisive. April 1st, 1942, Ypsilanti, Michigan. Charles Sorensen stood on a catwalk overlooking what had been, just months earlier, an empty field. Now it contained the largest factory building in the world, As Ford's production chief, Sorensen had overseen the construction of the massive Willow Run Bomber Plant, racing against both the calendar and widespread skepticism that aircraft could be mass-produced like automobiles. Cast Iron Charlie, as Ford workers called him, had personally sketched the initial factory layout on a drafting table at Ford headquarters in 1941. Where aviation executives saw insurmountable complexity, Sorensen saw assembly lines, standardized parts, and production efficiencies. Where aircraft manufacturers insisted each bomber required individual craftsmanship, he envisioned interchangeable components moving along conveyor systems. The plant itself represented an engineering marvel. The main assembly building was a single-story structure, nearly a mile long, with an adjacent airfield where completed bombers could taxi directly from the production line for flight testing. A dedicated railway spur delivered materials directly to the factory floor. The entire facility had been built in less than a year. But on this April morning in 1942, Sorensen faced a sobering reality. Despite the magnificent facility, actual bomber production remained far behind schedule. Components didn't fit together properly. Sub-assemblies arrived in the wrong sequence. Workers accustomed to automotive production struggled with aircraft tolerances and specifications. Willow Run had delivered exactly 0 completed bombers. The press was scathing. The Detroit News referred to Willow Run as "Will It Run?" Senator Harry Truman's War Investigating Committee questioned whether Ford had oversold its capabilities. Aviation industry executives, many of whom had opposed the Ford contract from the beginning, whispered "I told you so" in Pentagon corridors. Edsel Ford, Henry's son and the company's president, approached Sorensen that afternoon with mounting concern. "Washington's losing confidence, Charlie. They're talking about canceling the contract." Sorensen's response was characteristically blunt. "Tell them to be patient. We're not just building bombers. We're inventing how to build bombers." What Sorensen understood, and what both critics and German intelligence failed to grasp, was that Willow Run represented not just a factory, but a completely new manufacturing paradigm. The initial delays stemmed not from failure, but from the challenge of creating an entirely new production methodology. Traditional aircraft manufacturers built bombers through a station-to-station process, with the airframe remaining in one location while teams of workers sequentially assembled components. Willow Run would instead move partially completed aircraft along assembly lines while workers performed specialized tasks, exactly as Ford built cars, but on a vastly larger scale and with far greater complexity. By June 1942, the first production difficulties were being systematically resolved. Tolerances were standardized, jigs and fixtures were modified for greater precision. The workforce, initially composed largely of automobile workers, was supplemented by experienced aircraft technicians. Most importantly, the assembly line itself was reconfigured to accommodate the three-dimensional complexity of aircraft production. The first complete B-24 emerged from Willow Run on September 10, 1942. It represented not just an aircraft, but proof of concept. Mass production techniques could indeed be applied to bomber manufacturing. Production in 1942 remained painfully slow. The plant delivered only 56 bombers by year's end. But the groundwork had been laid for what would become the most remarkable industrial acceleration in aviation history. While Willow Run struggled through its early production challenges, German aircraft factories continued with traditional manufacturing methods. A Junkers factory report from October 1942 reveals the limitations of this approach. Production remains constrained by the availability of skilled metalworkers. Attempts to employ unskilled workers have resulted in unacceptable quality variations. Current output of 7 Ju-88 bombers weekly represents maximum capacity with available personnel. Indeed, the mathematical implications were becoming clear, though not yet fully apparent to either side. Willow Run was designed for an eventual production rate of 1 bomber per hour. The largest German bomber factories struggled to produce 1 per day. This tenfold differential would soon translate directly into Allied air superiority over Europe. As 1942 ended, the industrial contest that would decide the air war was being set in motion. The production curves were about to diverge dramatically, though the full impact remained months away. German intelligence continued to receive reports about American production goals, but assessed them as technically infeasible and propaganda for home front consumption. This assessment would soon be shattered by the reality of American industrial output. October 15, 1943. Schweinfurt, Germany. Oberstleutnant Heinz Schmidt, commanding the city's flak defenses, stared upward as hundreds of contrails crisscrossed the sky above the critical ball-bearing factories. Through his binoculars, he counted group after group of American heavy bombers, B-17 Flying Fortresses and B-24 Liberators, stretching from horizon to horizon. This was the second major raid on Schweinfurt in 3 months. The August attack had involved approximately 230 bombers. Today's raid included more than 300, despite the severe losses inflicted during the previous mission. "Where do they find so many aircraft and crews?" Schmidt asked his operations officer. "We shot down 60 bombers in August. Today they return with even more." What Schmidt couldn't know was that he was witnessing the mathematical reality of American production capacity. The Schweinfurt raids occurred precisely as Willow Run and other American factories were reaching full production momentum. Every bomber lost over Germany was being replaced by multiple aircraft, rolling off assembly lines in Michigan, California, Texas, and Oklahoma. The Willow Run plant alone had undergone a production transformation that German intelligence officers initially refused to believe. By October 1943, Ford's massive factory was producing 1 B-24 Liberator every 63 minutes. Workers operated in 3 shifts, 24 hours a day, 7 days a week. Production that month exceeded 340 complete bombers, more 4-engine heavy bombers than the entire German aircraft industry produced in the same period. The path to this production miracle had not been smooth. Throughout 1942 and early 1943, Willow Run had struggled with workforce issues, quality control problems, and the fundamental challenge of adapting automotive manufacturing techniques to aircraft production. The factory had been designed for 42,000 workers, but had difficulty recruiting and training enough personnel as men were drafted into military service. The solution came from an unexpected source: women. By mid-1943, nearly 40% of Willow Run's workforce was female. Women who had never previously worked in manufacturing were trained as riveters, welders, electricians, and inspectors. The iconic Rosie the Riveter wasn't just propaganda, she represented a critical workforce transformation that enabled American production dominance. Equally important was the standardization of components and processes. Early B-24s had required frequent modifications on the production line as design improvements were incorporated. By late 1943, the design had stabilized, allowing for true mass production techniques. Suppliers delivered components built to exact specifications that required minimal adjustment during final assembly. The production statistics told the story. In January 1943, Willow Run had produced 87 bombers. By December, monthly production exceeded 400. Each aircraft required approximately 25,000 man-hours to complete, compared to approximately 55,000 hours at the beginning of production, a productivity improvement of more than 50% in less than a year. This production revolution had profound implications on the battlefield. The 8th Air Force, despite suffering severe losses in 1943, continued to increase in size and striking power, German fighter pilots who shot down American bombers found themselves facing even larger formations weeks later. The simple mathematics of attrition, which had initially favored German defenders, was turning inexorably against them. November 3, 1943, Berlin, Germany, Reich Ministry of Armaments and War Production. Albert Speer, who had replaced the deceased Fritz Todt as Armaments Minister, studied the latest intelligence assessment of American aircraft production with growing alarm. The numbers seemed impossible, yet multiple sources confirmed their accuracy. Ford's Willow Run Plant is now producing over 340 B-24 bombers monthly, the report stated. Total American heavy bomber production exceeds 1,000 aircraft per month and continues to accelerate. Speer had previously dismissed reports of American production efficiency as exaggeration. Now, faced with photographic evidence and production statistics verified by multiple intelligence sources, he confronted a devastating reality. Germany was being overwhelmed not just by American resources, but by American production methodology. "We have been building aircraft like handcrafted timepieces," Speer later wrote in his memoirs, "while the Americans built them like automobiles." Speer immediately ordered a fundamental reorganization of German aircraft production, attempting to incorporate mass production principles and standardized components. But the initiative came too late. German factories had not been designed for assembly line production. The workforce lacked training in mass production methods. Most critically, Allied bombing was now systematically targeting the German aircraft industry, disrupting even existing production capacity. The mathematical reality was stark and unyielding. In 1943, Germany produced approximately 10,900 aircraft of all types. In the same year, the United States produced 86,000 aircraft, with production still accelerating. The disparate curves of these production rates weren't merely statistics. They represented the fundamental transformation of air power over Europe. The human drama behind these statistics played out daily in the skies over Germany. Luftwaffe pilots, increasingly outnumbered and flying older aircraft with limited fuel, faced waves of American bombers and their escort fighters. Colonel Johannes Steinhoff, a leading German ace, described the situation in his war diary. "We no longer face individual aircraft or even formations. We face an entire industry. They lose 20 bombers today and arrive with 25 new ones tomorrow. This is not a battle of pilots, but a battle of factories." By the end of 1943, the implications of America's industrial transformation were becoming apparent to German military leadership. General Adolf Galland, commander of the Luftwaffe fighter force, reported directly to Hitler, "The enemy's air superiority is no longer temporary or local, it is total. Our fighters are outnumbered 10 to 1 or more in every engagement. American aircraft production has exceeded our most pessimistic estimates." Hitler's response was characteristic: orders for even greater production using existing methods, demands for wonder weapons that would reverse the situation, and refusal to acknowledge the fundamental industrial reality. The mathematics of defeat were already established, though the fighting would continue for another 17 months. March 15, 1944, Willow Run, Michigan. Dawn broke over the massive Ford bomber plant as the midnight shift completed their work and day shift workers streamed through the factory gates. On the main assembly line, a completed B-24 Liberator, the 3,553rd, produced at Willow Run, moved steadily toward the factory doors. Behind it, another bomber was 55 minutes from completion. Behind that one, another would be ready in another 55 minutes. Charles Sorensen stood with a group of Army Air Forces officers watching as the enormous bomber, its olive-drab paint still fresh, rolled out onto the adjacent airfield where Ford test pilots waited to take it on its maiden flight. "Gentlemen," Sorensen said quietly, "we have achieved our goal, 1 bomber per hour." The production miracle that German intelligence analysts had dismissed as impossible had become reality. Willow Run was now delivering 24 bombers daily, operating 24 hours a day, 7 days a week. March production would exceed 600 B-24s, more heavy bombers than the entire Luftwaffe had in operational service on the Eastern Front. The path to this achievement had required solving unprecedented manufacturing challenges. Traditional aircraft construction involved building components that were then individually fitted together, with workers filing, trimming, and adjusting parts to make them fit. This approach was labor-intensive and resisted standardization. Ford's solution was revolutionary. Tooling and jigs of exceptional precision ensured that components would fit together without adjustment. Parts became truly interchangeable. Assembly workers didn't need to be skilled aircraft technicians. They needed only to perform specific standardized tasks as the aircraft moved along the line. Willow Run's physical layout embodied this philosophy. The factory was essentially a gigantic machine for building airplanes. Raw materials, aluminum sheets, steel tubing, wiring, engines entered at one end. Completed bombers emerged from the other. The central innovation was the moving assembly line itself. The main line stretched nearly a mile, but it wasn't a single line. It was a complex network of feeder lines where sub-assemblies were constructed before joining the main production flow. Wings, tail sections, fuselage segments, and nose assemblies were built on parallel lines, then brought together in precisely timed sequences. This production system required an unprecedented level of coordination. Ford employed over 1,400 industrial engineers at Willow Run, constantly refining processes and solving problems. The factory contained over 30,000 different tools and used over 900 machine tools. At peak production, it consumed 900,000 pounds of aluminum sheet each day. The workforce itself represented another revolution. By 1944, 42% of Willow Run's employees were women. African Americans constituted over 10% of the workforce. Despite initial resistance from Ford management, workers came from 48 states and included people who had never seen an airplane before joining the bomber plant. Rose Will Monroe, who worked as a riveter at Willow Run, became one of several women who inspired the iconic Rosie the Riveter character. The plant's diverse workforce demonstrated that aircraft production didn't require years of specialized training. It required well-designed systems and processes that enabled ordinary people to achieve extraordinary results. The production mathematics were staggering. Each B-24 contained 1,550,000 parts and 360,000 rivets. The factory used 67,000 drawings to define the bomber's components. At peak production, Willow Run consumed enough electricity to power a city of 300,000 people. More significant than these statistics was the production rate. When Willow Run reached full capacity in 1944, Ford was building one complete B-24 every 55 minutes. A bomber that had required approximately 28,000 man-hours to build, using conventional methods at the beginning of the war, now required less than 18,000 man-hours at Willow Run, a productivity improvement of 36%. The implications of this production revolution extended far beyond Michigan. They were felt most directly in the skies over Germany. April 11th, 1944, Reich Air Ministry, Berlin. Field Marshal Erhard Milch, State Secretary in the Reich Ministry of Aviation and Inspector General of the Luftwaffe, studied the latest intelligence assessment with growing despair. American bomber formations over Germany had grown from group-sized raids of 20 to 30 aircraft in 1942 to massive operations involving over 1,000 heavy bombers in 1944. "These cannot all be coming from Ford's factory," Milch said to his intelligence officer. "The numbers are impossible." But the reality was even more daunting than Milch realized. Willow Run was just one component of America's industrial mobilization. While Ford's plant was reaching its peak efficiency with the B-24, other factories were mass-producing B-17 Flying Fortresses, P-51 Mustang fighters, and P-47 Thunderbolts. The Consolidated Aircraft Plant in San Diego, Douglas Aircraft in Tulsa, North American Aviation in Dallas, all had adapted elements of Ford's mass production techniques to their own facilities. What had seemed revolutionary in 1941 had become standard practice by 1944. The mathematical realities were inescapable. In 1944, the United States produced 96,218 military aircraft, more than Germany, Japan, and the British Empire combined. This unprecedented production achievement translated directly into operational dominance. By spring 1944, the U.S. 8th Air Force alone could dispatch over 1,000 heavy bombers and 1,000 fighters on a single mission. These aircraft weren't arriving in Europe one by one. They were arriving in vast numbers, overwhelming German air defenses through sheer volume. Milch had attempted to implement mass production techniques in German aircraft factories after becoming aware of American methods. But the effort came too late and faced multiple obstacles. Allied bombing disrupted production, critical raw materials became increasingly scarce, and German industrial culture resisted fundamental changes to manufacturing methodology. Most crucially, German factories had not been designed from the ground up for mass production, as Willow Run had been. Retrofitting existing facilities proved far less efficient than building purpose-designed plants. While American production accelerated throughout 1944, German aircraft output struggled to maintain consistent levels despite Speer's and Milch's best efforts. The human cost of this production disparity played out daily in the skies over the Reich. Luftwaffe pilot Hans Joachim Jabs, who survived the war with 62 victories, described the psychological impact in his post-war memoir. By 1944, we'd no longer faced individual bombers or even formations. We faced an entire industrial system. Each B-17 or B-24 we managed to shoot down was instantly replaced by two more. It was like trying to empty the ocean with a teacup. The aircrews who flew these mass-produced bombers experienced a different reality. The B-24 had originally gained a reputation as a difficult, unforgiving aircraft. Pilots called it the flying coffin due to its high wing loading and challenging handling characteristics, particularly during takeoff and landing. Yet as production standardized and training improved, the Liberator became the workhorse of the American bomber fleet. Lieutenant James Thompson, a B-24 pilot with the 15th Air Force based in Italy, wrote in his diary after a mission to Ploesti in April 1944, "Our formation lost 3 aircraft today. When we returned to base, 5 brand-new B-24s had arrived from the States. That's what the Germans don't understand. We're replacing losses faster than they can inflict them." The mathematics of attrition had shifted decisively in favor of the Allies. German fighters might still win individual tactical engagements, but they were losing the strategic production battle by an overwhelming margin. June 6, 1944, Normandy, France. As Allied forces stormed the beaches of Normandy, the skies above belonged almost exclusively to Allied aircraft. Over 11,000 aircraft supported the D-Day landings, including hundreds of B-24s from Willow Run. The Luftwaffe managed barely 100 sorties in response, a vivid demonstration of how completely air superiority had shifted. This transformation had occurred with stunning rapidity. In 1942, the Luftwaffe had contested every Allied air raid over occupied Europe. By mid-1944, German fighters often remained grounded during daylight hours, unable to challenge Allied air dominance. The production statistics told the story. By D-Day, Willow Run had delivered over 4,600 B-24 Liberators. Total American production of the type would eventually reach 18,190. By comparison, the entire German aircraft industry produced just 1,893 Junkers Ju-88 bombers, their closest equivalent to the B-24, during the entire war. Albert Speer, who had been tasked with maximizing German war production, recognized the implications. In a report to Hitler dated July 28, 1944, he wrote, "The enemy's air superiority has a decisive impact on nearly all areas of the war economy. The American system of mass production, which we initially ridiculed, has achieved a scale that we cannot match with our existing methods." Speer had attempted to implement similar mass production techniques in German industry, achieving significant increases in output despite Allied bombing. But the fundamental advantage remained with the Americans, who had designed their production systems from the ground up for maximum efficiency and had access to virtually unlimited raw materials. The most revealing statistics concerned not just production totals, but production rates. At its peak in late 1944, Willow Run produced over 650 B-24s monthly. The most efficient German aircraft factory, the Messerschmitt plant at Regensburg, achieved a maximum production of 300 Me-109 fighters per month. And these were single-engine fighters, far less complex than four-engine heavy bombers. November 12, 1944, Merseburg, Germany. Major Werner Klumper of the Luftwaffe's elite JG-300 fighter wing watched with a mixture of awe and despair as more than 500 B-24s from the 8th Air Force's 1st, 2nd and 3rd Air Divisions approached the vital synthetic oil plant at Luna. The formation stretched from horizon to horizon, escorted by hundreds of P-51 Mustangs. Klumper led his fighters in a desperate attack against the bomber stream, knowing they were hopelessly outnumbered. Of the 36 Me-109 fighters that took off that morning, 11 would not return. The Americans lost 26 B-24s and 5 fighters in the engagement, significant losses by any standard. Yet these losses represented just 5% of the attacking force. More importantly, they would be replaced within days by fresh aircraft rolling off assembly lines in Michigan, Washington, and California. The mathematics of attrition had become insurmountable. The 8th Air Force alone was receiving approximately 400 replacement aircraft monthly, more than the entire Luftwaffe fighter force facing them. American factories were producing combat aircraft faster than they could be destroyed in battle. For German pilots, the realization was psychologically devastating. Their individual skill and courage, even when successful in tactical engagements, could not overcome the fundamental strategic reality. They were fighting not just American air crews, but the entire American industrial system. Hans Busch, a Luftwaffe pilot who survived 122 combat missions, later wrote, "We began to understand that this was not a contest of pilots, but of factories. Each American bomber contained more aluminum than 10 of our fighters. They were building these massive machines in such numbers that our eventual defeat was merely a mathematical certainty." The cruel equation became clearer with each passing month. By late 1944, the Luftwaffe was losing experienced pilots faster than they could be replaced. Training hours for new pilots had been reduced from 200 to less than 80 due to fuel shortages. American pilots, by contrast, received over 400 hours of training before combat deployment. The disparity extended to every aspect of air operations. While German aircraft increasingly relied on substitute materials due to strategic shortages, American bombers continued to use optimal alloys and components. While German maintenance crews struggled with parts shortages and makeshift repairs, American logistics ensured standardized replacement parts for every aircraft. The impact of these diverging trends was felt most acutely by German civilians. As 1944 progressed, American strategic bombing penetrated deeper into the Reich, striking targets that had once been considered safely beyond reach. Liberators from Willow Run participated in raids against Berlin, Leipzig, Munich, and dozens of other German cities. The defensive response revealed Germany's production dilemma. The Reich had diverted significant resources to anti-aircraft defenses, deploying over 15,000 flak guns by late 1944. These formidable defenses extracted a toll on attacking bombers, but consumed massive resources that might otherwise have supported frontline forces. Even this defensive effort could not overcome the mathematical reality. American factories were producing bombers faster than flak batteries could shoot them down. January 16, 1945, Willow Run, Michigan. As winter snow blanketed the massive factory complex, production continued unabated. The plant had by now achieved a level of efficiency that would have seemed impossible just 3 years earlier. The 8,685th and final B-24 produced at Willow Run rolled off the assembly line that day. Ford was already retooling portions of the factory for C-87 transport production as the strategic bombing campaign against Germany entered its final phases. The production techniques pioneered at Willow Run had been so successful that they were now being applied to next-generation aircraft. Charles Sorensen, who had overseen the plant's development from concept to peak efficiency, had left Ford in 1944 after a disagreement with Henry Ford. But his legacy was secure. He had transformed aircraft manufacturing from a craft-based process to a true mass production industry. The numbers told the story of his achievement. Willow Run had delivered 8,685 complete B-24 bombers in just over 3 years. The plant had achieved and sustained production rates that German intelligence analysts had initially dismissed as impossible. 1 bomber per hour, 24 per day, 7 days per week. More significant than the raw production statistics was what they represented: the triumph of American industrial methodology over traditional manufacturing techniques. Ford had proven that even the most complex military aircraft could be mass-produced using automotive assembly line principles. The implications extended far beyond the war effort. Willow Run had demonstrated that large-scale, complex machinery could be built by workers with limited specialized training if the production system itself was properly designed. This insight would transform post-war manufacturing across multiple industries. May 8, 1945, Berlin, Germany. As Germany surrendered unconditionally to Allied forces, the mathematical reality that had determined the war's outcome became clear in the final statistics. During World War II, the United States had produced 300,000 military aircraft, more than Germany, Japan and Italy combined. This production miracle represented not just material superiority, but a fundamental transformation in manufacturing philosophy. American industry had reimagined how complex machines could be built, applying mass production techniques to challenges previously considered unsuitable for assembly line methods. Albert Speer, interviewed by Allied intelligence officers after the surrender, offered perhaps the most insightful assessment. The fundamental difference between German and American war production was philosophical rather than material. We believed that precision machinery required craftsmen. You proved that properly designed systems could enable ordinary workers to build extraordinary machines. The B-24 Liberator became the most produced American military aircraft in history. Of the 18,482 built, nearly half came from a single factory, Willow Run, that German intelligence had initially dismissed as fantasy. For the workers who had made this achievement possible, VE Day represented vindication of their efforts. Many had relocated from across America to the hastily constructed town of Willow Run, living in dormitories and temporary housing to support the war effort. They had endured long hours, challenging working conditions, and the constant pressure of production quotas. Edith Griffith, who worked as a riveter at Willow Run throughout the war, later recalled the moment she heard of Germany's surrender. "I stood on the assembly line and thought about all those bombers we'd built. Over 8,000 from our factory alone, each one with a crew of 10 men. We didn't just build airplanes, we built victory." The transformation from mockery to grudging respect occurred gradually in German military circles as the reality of American production capacity became impossible to ignore. What had begun with dismissive laughter in 1941 had ended with the acknowledgement that American industrial methodology represented a revolution in warfare. Reich Minister Albert Speer, writing from his cell at Nuremberg in 1946, provided the final epitaph for Germany's fatal miscalculation. "The decisive mistake we made was believing that quality could compensate for quantity. What we failed to understand was that American production methods achieved both simultaneously. They built better aircraft in vastly greater numbers than we had believed possible." Ford's achievement at Willow Run wasn't just a production miracle. It was the death knell of our entire approach to industrial warfare. In the decades following World War II, the lessons of Willow Run transformed manufacturing worldwide. Japanese and German industry, rebuilding from wartime destruction, studied and adopted American mass production techniques. The automotive assembly line principles that Ford had applied to bomber production would eventually return to influence car manufacturing around the globe. The B-24 bombers themselves were largely scrapped after the war, their aluminum recycled for peacetime uses. Willow Run transitioned to civilian production, eventually manufacturing automobiles for General Motors. Today, only a handful of airworthy B-24s remain as flying memorials to the nearly 18,000 that once darkened European skies. But the true legacy of Willow Run extends beyond the aircraft it produced. It demonstrated how industrial methodology could be as decisive in warfare as tactical doctrine or fighting spirit. The factory that German intelligence officers had once laughed at as an impossible fantasy had not merely built bombers, it had established the production paradigm that would define modern industrial warfare. Charles Sorensen, reflecting on Willow Run's achievement years after the war, offered the simplest assessment. "They said it couldn't be done. We did it anyway. Not because we were cleverer than anyone else, but because we refused to accept that aircraft manufacturing was fundamentally different from any other kind of production." The greatest invention at Willow Run wasn't a machine or a process. It was a new way of thinking about what was possible. The transformation from skepticism to reality was captured most eloquently by President Franklin Roosevelt, who visited Willow Run in 1942 when the plant was still struggling to meet production targets. Surveying the vast facility, he remarked to Charles Sorensen, "This isn't just a factory, it's a temple of production. And when this war is won, it will be won on assembly lines like this one." 3 years later, as B-24s from Willow Run participated in the final bombing missions over Germany, Roosevelt's prediction had been validated. The factory that German intelligence had laughed at had helped deliver the mathematical certainty of Allied victory, one bomber every hour.